machines. So we will start with understanding the architecture diagram first. But you might have a question, Abhishek, why can't we run and deploy the model using the same simple steps that we implemented in the previous section? So basically in the previous section, when we learned what is this intent classifier model, we deployed the model onto the local machine or onto the virtual machine using some basic commands. So we ran the git clone to download the code. Then we ran train.py to create the model. And finally, we ran app.py to create API for the model. In fact, towards the end of the previous section, we access the API. So we send the request to the API. From there, request is sent to the model and model served the request back to the user. So typically we deployed the model and we also learned model serving using these simple commands. So what is the purpose of implementing this complex architecture? We can basically go with this architecture. Now let me tell you, this is a very, very good question. In fact, only when you understand challenges with this architecture, you will be able to implement the right production level architecture. So let's start with understanding the problems with this architecture that we implemented in the previous section. So the first major problem, when you ran Python app.py, you must have realized the Flask framework, which we used in the app.py, triggers a development server. Now, if you even observe the name, this is called the development server, not the production server, because the development server is not designed for concurrency. That means the development server works absolutely fine when you have 2 to 3 users, but when your API receives requests from 100 users or it receives concurrent requests from 1000 users, development server is not designed to handle the load. Now this is a roadblock or this is a blocker because let's say you're working in an enterprise. You're working for Netflix for a recommendation model. Now parallelly, multiple users across the globe will log into Netflix. So the login service of Netflix will send thousands of API requests to the recommendation model API. So your recommendation model API should be able to handle thousands of requests. Now, in this case, the recommendation model is served by the development server. By default, the development server lacks the functionality. So this is the problem number 1. Now, problem number 2. Again, if you observe carefully, when you ran Python app.py, the program or the process is running as a foreground process. You can actually try it, run Python app.py using your putty or using your terminal. As soon as you close the terminal, the session will be closed and your API will stop working because the development server is running as a foreground Linux process. Okay, Abhishek, you can basically run it as a background process. That's not a big deal. You can actually run it, but even if you run it as a background process, if your Linux virtual machine restarts for some reason, after the restart, the background process will not run. So this is the problem number 2. That is short lifespan of the foreground process. Problem number 3. In real time, a single virtual machine cannot handle loads of requests. Let's say a single virtual machine that you created is created with 16 CPU, 16 GB RAM, or you provided 32 CPU, 32 GB RAM. At some point, your resources will be exhausted, right? Your 32 CPU, 32 GB RAM cannot handle 10,000 requests, or maybe cannot handle 40,000 requests. So after a point, the virtual machine resources will exhaust. So you need maybe another virtual machine, or you need few virtual machines depending upon the load your model has to serve. If it is Netflix, maybe they need 10 virtual machines. If it's a startup, they might need 2 virtual machines. And even in today's world, the requirement can be pretty dynamic. That means in morning, you might only need 2 virtual machines. Whereas in the evenings, you might need 5 virtual machines. So you don't need a static scaling, but you need a dynamic scaling. Right? I hope you got the requirement. Maybe your model is used by 1,000 users in the morning, but in the evening, during the peak time, your model is used by 10,000 users because more people watch Netflix in the evening, let's say. So you need a dynamic scaling to prevent excessive costing on the cloud platform. You can have 10 virtual machines all the time, but you will be paying for 10 virtual machines throughout the day, throughout the month, throughout the year. So to reduce the costing, you need dynamic scaling. Now, whenever there is dynamic scaling or whenever you have multiple instances, quite obviously, you need a load balancer. Why? Because there is no point of having multiple virtual machines without a load balancer or without something that can balance the load between virtual machines. Let's say you receive 3,000 requests. Load balancer can send 1,000 requests to first virtual machine, 1,000 requests to second, and 1,000 requests to the third one. So that's why you also need a load balancer. Now, all of these are the drawbacks of the architecture that we implemented in the previous section. On top of that, a single virtual machine, we haven't implemented the custom networking, we haven't implemented the subnets, so we haven't dealt with networking part as well. Now, the current architecture that we are going to learn in this section will address all these problems. Now that we understood the problems, let's try to understand how this architecture solves this problem. So we will understand this in a very, very simple way. The first problem, right? So the first problem, custom networking, it's very easy. We will start with a virtual private cloud on the cloud platform. So basically we will create a VPC. Within the VPC, we will create subnets, we will create route tables, we will create internet gateway, all the default resources. Problem number 2. The previous architecture was running a development server. So the concurrency was a problem. This problem can be addressed easily using WSGI, Web Server Gateway Interface. And in fact, today, if you ask 5 to 10 years ago, implementing WSGI might have taken a lot of steps. But today in Python, you can add WSGI with just 2 lines of code. So 2 lines of code can convert your development server to a production grade server. We will just install the WSGI module and we will run WSGI with parallelism of 3, 4, 5, depending upon load of the users, right? So WSGI can solve the problem of development server. I'll show you in practical. Then problem number 3, dynamic scaling. This can be solved using auto scaling group, right? The best part of cloud providers is that they offer auto scaling group. So you can just create auto scaling group. You can provide with the launch template, and every time there is a scale, every time, from 1,000 users, let's say request goes to 5,000 users, auto scaling group automatically understands, okay, the current virtual machine, CPU and memory is being exhausted. So let me create a new one. And when it creates a new one, it looks at the launch template, a script that you have to provide, and it will create the virtual machine. It will run the script within the virtual machine so that all your configuration, such as the model, such as the API for the model, everything is ready within the virtual machine. Finally, the fourth thing, load balancer. Now I don't have to tell you, cloud providers today offer load balancers. So with few clicks of button, you can create a load balancer and you can add the auto scaling group as the target group for the load balancer. Right? That's all. Very simple architecture. If you have DevOps or cloud fundamentals, this should be a cakewalk for you. Now let's try to understand the user flow. Whenever user sends a request to the model, this time request does not hit the API directly, but request goes to, from the internet gateway, request goes to the load balancer. From the load balancer, request goes to the target group that is configured, which is auto scaling group. And auto scaling group creates multiple virtual machines according to the load. So load balancer's request, if load balancer receives 300 requests, 100 goes to this virtual machine, 100 goes to this, and 100 goes to this virtual machine. And auto scaling group takes care of spinning up new virtual machines. And on every new virtual machine, it takes care of downloading the code. It takes care of running the train.py, app.py, basically making the API ready with web server gateway interface. Perfect. So these are the steps that we are going to perform as part of the architecture. One final time. Right? Let's try to understand the user flow one final time before we implement the architecture. So from the internet or from the users, request goes through the internet gateway of the VPC. So when we create the VPC, we will create the internet gateway. So from there, request goes to the load balancer. When we create the load balancer, we will add a target group, and that target group will be auto scaling group. So because auto scaling group is added as a target group, it will create virtual machines, and within the virtual machines, it will run the API, it will run Nginx, it will run WSGI, everything required to make the development server a production server. So once the virtual machine is ready, load balancer forwards request to this virtual machine and request is served. This way, model deployment and model serving is implemented in real time. I hope the architecture part is clear. I'll also provide detailed notes in the GitHub repository. Make sure you quickly go through that as a revision material. In this lecture, let's see how to run our intent classifier model using the web server gateway interface, that is using WSGI. In the previous section, we already learned how to run it locally and how to get the response from the model using the API. So for this lecture, I'll take an EC2 instance. So you can also create an EC2 instance. I just created one using Ubuntu. So I'll first log into this instance. So I'll take my terminal and SSH to the instance. Perfect. So SSH using the PEM file, Ubuntu @public IP address. There you go. I logged into the instance. Now the first step, I will clone the repository. To be honest, most of the steps are very similar. How you run the model locally and how you run it using WSGI. Okay, so I need the git clone URL. So I'll head to my GitHub repository, look at the clone. Perfect. So copy this URL. Going back to the terminal, I'll create a directory here. Let me call this as OPT, cd OPT, and I'll run git clone followed by the URL. Perfect. Now let's switch to the directory, intent classifier model. Now, every time you run a Python project, as I told you multiple times in this course, let's start with creating a virtual environment because we are going to install the dependencies for the project. So Python 3 -m venv.venv. Perfect. So the virtual environment is set up. Now let's source the virtual environment. Source.venv bin activate. Perfect. Now the first thing that we'll do is to download the dependencies. But before that, because we want to set up WSGI, let's first understand how to set up that. It's actually very simple. Now with your existing files, add a new file here called wsgi.py. And in this file, just provide from app import app. So basically, we are importing the app that we have created using Flask. And now I will call this as like using this variable application is equals to app. Now the web server gateway interface, this will look at this variable and it will understand, okay, so this is the API it has to expose. Perfect. So let's save this file. This is all you need to write within this file. Now in the requirements.txt, add a new dependency, which is called gunicorn. Basically green unicorn. Green unicorn is the one that implements WSGI for Python. In fact, it makes it so simple. All that you have to do is to add gunicorn dependency in the requirements.txt and create a very simple wsgi.py file. Trust me, if you're dealing with other programming languages, this process becomes complicated, but with Python, it's super simple. Okay, now we have the virtual environment, we have the files. So the first thing that we do is Python 3 -m pip install -r requirements.txt. Okay, this step is the same thing that we did in the previous section. Once all the packages are installed, even the next step that we do is the same. That is to create the model, right? Before we execute the API, we need the model. So we'll do that. Python 3 model. Within the model folder, we have the train.py. Now when we run this, an artifacts folder is created, right? So now if you look at model, you should find the artifacts folder. And within the artifacts folder, we have intent_model.pkl. Perfect. So now instead of running, so previously we ran this command Python 3 app.py, and this created a development server for us. Now the only difference is that we will run gunicorn command. So we will run this command. Gunicorn. So let me just remove the entire path. So this is all you need to run. Gunicorn -workers 3. So this workers represents the parallelism. We learned in the theory part, right? What gunicorn or WSGI brings into picture? It brings the parallelism so that concurrent requests can be served using the server. So we have the API running within the server. Now, if the server is capable of parallelism, indirectly, your API can also serve the parallelism. And we are binding the local port. We are using the same port 6000 WSGI:app. Okay, let's run this command. There you go. So now the process is running on port 6000. Now we can take a different tab. Let's duplicate the tab. Okay, And here again, I'll SSH to the virtual machine. And on the new tab, I'll just run the curl command. Curl, you can run it using the instance IP address, or you can also run it using the local host 127.0.0.1 colon port 6000 / predict is the API. I mean endpoint. Now -h, okay, we are passing application JSON as the header type, and this is the text that we are passing to the post request. Hi, what's up? Now we should see the response back. So who is serving this request? Now this request is not being served by the development server, but this is served by the WSGI. Now if I click on the enter, there you go. Intent is greeting. So you can also see the response is being served using this GUnicorn. So it's almost the same. That's what I was trying to say. Whether you are running using the Flask development server or GUnicorn, you will run similar steps. Only thing is that with WSGI, you will add a new dependency. You will run the GUnicorn command instead of Python 3 command. Perfect. Now I hope you know how to run your API using a production grade server. In the next lectures, we will run how to set this up as a Linux service. Right now, if you see here, if I click on Control C and I'll take a different tab. If I run this curl command, request is not served. Why? Because even though we are running a production grade server, we are running it as a foreground service. So either we can run it as a background service, or we can run it as a systemd process or the Linux process, Linux service. We will do that, right? So that if we set it up as a Linux service, even if the virtual machine is restarted, because this is running as a Linux service, it will continue to run after the restart or after the reboot. Perfect. So for now, I hope you understood about WSGI. In this lecture, let's implement the user data script for this project. Of course, we briefly learned about the concept of user data script in the previous lecture. In this lecture, let's deep dive and also learn how to write this script. So if we go back and start from the previous lecture, we discussed about auto-scaling groups. Now in today's world, whether you are dealing with traditional applications or ML workloads, auto-scaling group has become very common. The reason is simple. In 2025, it is very difficult to predict the user traffic. Let's take an example. Imagine you are working on a model, you created a virtual machine, and within this virtual machine, you deployed the model and you expose the API for the model. Now, obviously, when you created this virtual machine, it comes with dedicated resources. Let's say you created this with 16 CPU, 16 GB RAM. Now, whenever there is a user request goes to the API serves the request, and while it is serving the request, whether it is the model server, API, they all utilize the underlying resources of the virtual machine. Now, let's say there are 100 user requests concurrently. Your 16 CPU, 16 GB RAM might serve the purpose. But what happens when there are 200 requests? Or let's say when the user request goes to 1000. Now this time, a single virtual machine with dedicated resources cannot handle the requests. Now at this time, user will start experience the slowness, or user will see the API as down. Now to avoid this, what companies usually do is they set up multiple virtual machines. And on each virtual machine, they deploy the model and set up the API configuration. Basically, all the virtual machines are set up in the identical way. Now, the problem with this approach is that While this solves the purpose, having dedicated set of virtual machines results in huge costing for the organization. So let's say organization creates 10 virtual machines because the maximum user traffic that they can expect is 10,000, let's say. Now, definitely, even when 10,000 user requests are invoked concurrently, because you have 10 virtual machines, all these virtual machines parallelly serve the request to the users. So your problem with user traffic is solved, but imagine a situation, let's say 3 a.m. in the morning or 6 a.m. in the morning, 8 a.m. in the morning, where your user requests are only 100, but you have 10 virtual machines running. So this will lead to huge cloud costs. So while your problem is solved, but still a new problem is created, that is cloud cost. So to avoid this, cloud providers introduce something called auto scaling group, right? So what auto scaling group does? It will increase the load, it will decrease the load according to the user traffic. So initially you can define, I need 2 virtual machines. So auto scaling group creates 2 virtual machines for you. And when it sees that these virtual machine resources are 80% consumed, let's say, it automatically creates a new virtual machine. And when all 3 virtual machines reach 80%, it creates a new virtual machine. And you can define a threshold on this auto scaling group. If you say threshold as 10, it will keep increasing the virtual machines till the point the number of virtual machines reach 10. In the same way, as the user traffic goes low, auto scaling group also starts terminating the instances. So this way, it solves both the purpose. The first purpose, it can handle the user traffic. Second purpose, it also keeps the cloud costs low by creating the instances only when they are required, right? So auto scaling group is very important for the organizations. But Abhishek, now where did user data script come into picture? Very simple. So auto scaling group creates new virtual machines, but you just don't need virtual machines. You need virtual machines with configuration. Imagine auto scaling group just creates a virtual machine. It does not have model in it. It does not have API running in it, and it does not have the required packages. Then this virtual machine is of no use because load balancer forwards the request to this virtual machine and it returns 404 or it returns a vague error back to the load balancer. So that's why auto scaling group should create the virtual machine along with the configuration. And this configuration is provided to the auto scaling group with something called as launch template. Okay. So what is this launch template? In the launch template, Cloud Engineer provides information like what is the OS distribution? What is the image name? Along with that, what is the user data script? So this user data script will be executed during the creation of the virtual machine, right? Again, I'll try to make this simple. So what auto scaling group does, it will look at the launch template. The name itself says launching template. So it will look at the launch template. According to the launch template, according to the parameters provided in the launch template, it will create the virtual machine. And during the creation of the virtual machine, while virtual machine is starting, it will execute the user data script provided in the virtual machine, provided in the launch template, my bad. And this launch template, it executes this user data script so that all the packages like model, API, and everything is installed on the virtual machine. So the virtual machine is absolutely ready to receive the traffic, or the virtual machine is ready to receive the request from load balancer. Perfect. So the whole purpose of the user data script is to install the configuration. Now, in our case, what configuration are we talking about? We are talking about running the model, creating the API, creating Python virtual environment, installing the dependencies, right? Then running the model, then running WSGI, and also running Nginx web server. Basically Nginx as reverse proxy. You can ignore this or you can keep it as optional, but I would prefer this only because, instead of having your API directly receiving the request and sending it to the model, it's always good to front face it with a reverse proxy like Nginx, so that Nginx can implement in future. If you want, you can implement SSL using Nginx. You can implement rate limiting using Nginx. You can implement denial of service attack using Nginx and other security related features, right? So Nginx is optional. It's not mandatory, but it is definitely good to have. Now that it is clear, right? Now that the user data script concept is clear, let's go ahead and write the user data script. Very simple. It's just a shell script. So I will take my Visual Studio Code, right? I have already cloned the source code in it. Now within the Visual Studio Code, I will start writing the script. And then we will test the script before we head to creating auto scaling group in the future lectures. And one important thing here. So because we are using intent classifier model for all the deployment strategies, the common code will be in the main branch, like the common code like the train.py, app.py, wsgi.py, everything basically for running the model on the local machine will be in the main branch. But if you look at the different branches, you will find a branch called virtual machines. Now within this virtual machines branch, right now it's not available, but once you see this course live, within this branch, you will find the complete details on how to use the virtual machines deployment strategy, like the user data script that I'm going to write, the steps that I'm going to perform to deploy and serve model on AWS. Everything will be shared in the virtual machines branch. So this way I'm planning to use branches. In the next deployment strategy, let's say the Kserve strategy, you will find a branch called Kserve. On the Kubernetes, you will find a branch called Kubernetes. So it's easy. Whichever deployment strategy that you want to learn, you can just switch the branch. You can go to that branch and follow the steps. Cool. So going back, VS Code. Perfect. Now I'm already in the branch. So I'll create a new file. I'll call it as userdata.sh. Perfect. As I told you, this is just a shell script. So I'll start with shebang /bin/bash. What exactly are we going to write in the script? We already discussed. We will be writing these things in the script. But anyways, let's add comments so that it is very clear what exactly we are going to write in the script. So the very first step that we will do in the script is to create a directory, the directory where we will clone the repository. Then in the second step, we will update the packages because these are newly created virtual machines. Always we should update the packages. Then once the packages are updated, we will run git clone to download the source code. Perfect. Once we have the source code, we will set up Python virtual environment and we will source the virtual environment. Once that is done, we will install the Python dependencies using pip install or using requirements.txt, right? There you go. Then once dependencies are installed, we will run the model. Cool. Once the model is run, it will create the .pkl file. So then we will execute WSGI, but this time as a Linux systemd service. Then we will install Nginx as Linux systemd service. Finally, we will enable these services so that even during the restart, the services will go back to the running state. Once the virtual machine is restarted for any reason, after the booting, you will still find these services running so that API can still serve the request. Cool. So these are the steps 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's start with writing the script for these 9 steps. So once again, where will you find this script? Once the lecture is done, just go to the GitHub repository. Don't look for the main branch, but look for virtual machines branch. Okay. The first step. Okay. What are we doing? We will set, so just set -e. Now let's start writing the script. First thing is to create the directory. Okay. Let me export a variable called app directory. I will use this directory location /opt/intent app. You can go with any name here. And then I will run mkdir-p because this is a nested directory. I have to use -p followed by $app directory. Cool. So first step is done. Not really. We should also switch the directory. My bad. cd app directory. Okay, now we are done with the first step. Second step, update the packages. It's very simple. We all know apt update -y. And then we will also install the common system dependencies in the same step, like apt install -y get python 3 -venv space python 3-pip and nginx. But Abhishek, why do we need this? Because on AWS, you have these dependencies out of the box. What is the point of installing them? I don't install when I create a virtual machine. You are right, but what if someone is using a different virtual machine? Maybe someone might be trying this script on their Ubuntu local virtual machine, or they might be using a Debian distribution. So just keeping everyone in mind, I am installing the required dependencies. Cool. What is the next step? Git clone. Let me copy the path. Great. So this is the command. Git clone followed by the intent classifier model git repo followed by the dot. Okay, awesome. So we have the Git repository also cloned. Now the next step is to install the Python virtual environment. Python 3 -m venv.venv source.venv bin activate. Okay. So we also set up the Python virtual environment. Another thing that we'll do in this step is we will just upgrade the pip. Pip install -upgrade pip. Cool. What is the next step? So we also install the Python virtual environment. Now let's install the Python dependencies. Okay, that's very simple. Let's do it. Python 3 -m pip install, -m pip install -r requirements.txt. Let's be very clear with the spellings. Okay. Python 3 -m pip install -r requirements.txt. Sounds good? What is the next step? We also did this. Next step is to run the model. Again, it's very simple. Python 3, what is the folder? Model slash train.py. Why I'm choosing this folder? Because here the train.py is within the model folder. That's it. Okay, so we are done with this step as well. Now we should run WSGI as Linux systemd service. If you just have to run WSGI, you can just run gunicorn followed by followed by the command. But in this case, we have to run it as a systemd service. So this is what we should do. Configure gunicorn systemd service. I already have the script part, so I just pasted it. Basically, we will create this file within the systemd folder /etc systemd system intent gunicorn.service. You can keep any name. You can keep the name as Abhishek. You can keep the name as XYZ. It's totally up to you. Whatever is the name of the service that you want to provide. But what is important? This is the important part. Only this block here. With which user you want to run this service? So the user is Ubuntu, group is Ubuntu. In which directory? This is the directory. And this is the exec start command. In fact, this is the most important one. So we are saying run this command within this virtual environment. What is the command? gunicorn -worker3 bind address followed by wsgi:app. It might look to you like multiple lines, but in fact, most of it is metadata. Only thing that changes from service to service is this particular exec start command. Okay. Then we also want to run Nginx. So for Nginx as well, we will create a file here. So let me copy paste the Nginx file configuration. There you go. So cat within etc nginx config.d intent app.conf. So I'm creating Nginx configuration here. And here I'm saying whenever request is received on port 80 and on the location / forward the request to this particular URL. What is this URL? This is the URL where you have the API running. So let me explain through the notepad or the whiteboard what exactly is Nginx configuration doing. Very simple. So you are telling Nginx, hey Nginx, act as a reverse proxy. Whenever someone sends a request to you, forward the request to 127.0.0.1:6000/predict endpoint. So if someone sends a request to Nginx, that is, if someone sends a request to localhost:80/, because Nginx by default is running here. So localhost:80/. If someone is sending the request there, forward the request to this particular IP address, port, and the endpoint. Cool. So this is where the API is running. So Nginx will forward the request here and user request will be served through this endpoint. So going back. Okay, this part is also clear. We are using the proxy pass. Finally, we have to start this Nginx service as well as the gunicorn service that we have created. Systemctl, enable the intent gunicorn service and enable the Nginx service. We are also using start and restart so that in case of virtual machine restart, the service will be restarted. Let's say you made any configuration changes. That's it. Perfect. So this is the script that we prepared. Now, how do we test the script? Because Abhishek, this script will be provided as part of the launch template. And if something goes wrong, we will come to know about it only when we initiate a auto scaling group. Don't worry, we will follow a very simple technique. So basically, we will create a new virtual machine. Okay, so this is the strategy that we'll follow to test the script. We will create a new virtual machine, and this virtual machine will not have any configuration, right? It will not have the model, it will not have the API. So then we will copy the script to this virtual machine and we will execute the script. Once the script is executed, we will verify if API is running and Nginx is able to forward the request to the API. That's it. If that is successful, then our script is working fine. Let's do that. Now on AWS, let's create a fresh instance. Okay, we'll not use the existing instance that I've already used for showing you how to run this model and how to run WSGI, because there is some configuration in there. Let's create a new instance. Only requirement is that we should create a Ubuntu instance. Let me call this as test server. I'll choose Ubuntu because the script that we wrote is for Ubuntu. Then I'll keep T3 micro, that's fine. Key value pair, the one that I have on my local machine, I'll use it. And I'll keep all the configuration the same. Only I'll allow HTTP traffic. All set, click on launch instance. Now, once the instance is launched, I'll take the terminal, log into this instance or SSH to this instance and run the script. Cool. So looks like the instance is already up, which is a great thing. I'll take the terminal. Perfect. Here, I'll run the SSH command. SSH. So I need the IP address. Let me get that. There you go. IP address and tada. So now we are SSH to the virtual machine. Now let me go back to VS Code, copy the script. Cool. And paste it here. I'll call it test.sh. Great. Now, all that I have to do is to execute the script. chmod 777 test.sh followed by sudo /test.sh. Why am I running this as sudo? Because auto scaling group will use a launch template and user data script will be executed as the root user. Perfect. Let's run it. Now, one thing to remember, I wrote this script without using AI or something. So there can be some typos, there can be some issues with the script. So in case of any issues, let's try to fix the script live, right? Instead of stopping the recording and all, I'll try to address the issue if at all there is something. This will take up to 1 to 2 minutes because, like I told you, you must have looked at the comments as well. It has to install the dependencies, it has to install the model, it has to install system dependencies, Python dependencies, set up the services. So overall, it will take up to 1 to 2 minutes. Okay, there you go. So the script is complete. I can see that Nginx is already enabled. Anyways, let's run the WSGI related command first. That is, let's see if the API is running. So for that, I will run this curl command, the one that we used in the past as well. So curl -x post on the local host, port is not 5000. In our case, port is 6000. /predict is the API and hey, good morning. There you go. So we got the output as intent greeting. What does that mean? This means systemctl status intent _ G unicorn. This is the web server gateway interface service that we are running. And this is in the active state. Okay, I missed something here. Systemctl. Now if I run this, Because this is active and running, that's why we got the response back. And you can see here, this is actually running the command that we provided in the intent gunicorn.service, or we provided in this particular file. Cat, this file, you will notice what is this doing? This is executing this command. And because this command is executed, because gunicorn is running, that means the API is running on this particular location and predict endpoint. That's why when we run this command, we got the output back. Now let's also test Nginx. So for that, I'll run curl localhost :80, the port, followed by /. But we cannot send the GET request, so we should be sending the POST request. Okay, let's send POST, followed by the header as well as the JSON data. Okay, let's paste it here. Again, we got the response back, but this time we got it from Nginx. You can also verify it from the browser, right? So, you need a REST client or something. Instead, you can actually do this. For example, get the IP address, the public IP address, go back to the terminal, and instead of the local host, you can actually try the public IP address as well. Because Nginx is listening as a reverse proxy. Even when you hit on the public IP address, request is received by Nginx, and this request is forwarded to this particular IP address. Let's see. Tada, we got the output intent as greeting. You can also change this. Let's say instead of hey, good morning, let's say I want to cancel my subscription. You will see this intent as complaint. So this means our user data script is working absolutely as expected. And the good news is that we completed the majority part of this architecture. Although we haven't created the VPC, we haven't created the load balancer, but let me tell you, we have completed the toughest part. The rest of it is very, very simple. We will use the AWS console and we will create them. You will find it cakewalk. So what did we learn? We learned how to implement WSGI, and we also learned how to implement the user data script. In the next lectures, let's start creating the architecture. That is from VPC to load balancer, auto scaling group, subnets, everything. So this is about user data script. And associating it with the load balancer. And for this lecture, I have documented end-to-end steps in the GitHub repository. So if you just head to the virtual machines branch, so go to our intent classifier model repo, head to the virtual machines branch, you will find complete model deployment.md. And here you will find all the steps that we are going to execute. And the best part is that we will use automation. So instead of creating resources manually on the AWS console, which is an anti-pattern, we will actually go with AWS CLI commands. However, once the resources are created, I will use the AWS console to show you that the resources are created and how they communicate with each other. Perfect. And once you are done with the lecture, of course, you should delete the resources because it would incur cloud costs for you. So I have also created a document here, delete resources.md, in the same branch where you will find the exact steps and the order of deleting the resources. So you don't have to worry about the cloud costs. Perfect. Now, what is the order of resources that we will create, right? That is the only thing that we are left to understand. So the order of resources is very straightforward. We will first start with virtual private cloud. I'm sure if you followed our AWS Zero to Hero series on YouTube, you already know the order of creating resources. But anyways, I will repeat it. So first, we will create a virtual private cloud because all the resources will be created within this VPC. So we will use CIDR something like 10.0.0.0-16. Of course, you can use 24 as well, but anyways, we'll use 16. And then we will create subnets within the VPC. Why subnet? Why subnets, not a single subnet? Because we will be using a load balancer, and in AWS, when you create ALB, ALB should be associated with two different subnets in two different availability zones. So one per availability zone. That's why we will create two subnets. And we will make these subnets public because we will also try to connect to the instances. So to make the subnet public, by default in AWS, subnets are not public. You have to associate the destination route that is attached to the subnet to internet gateway. That's why once we create the subnet, we will create internet gateway, right? And then we will create route table. We will create a route where within the route, we will associate the destination to internet gateway. And finally, we will attach these route tables with subnet. That way, a subnet can become public. And once we have the subnet, internet gateway, route table, route, the core networking created, then we will create security group. So the reason for creating security group, let's say there is any issue with the virtual machines, or let's say there is any issue with the model deployment, we want to log into this virtual machine or connect to it and troubleshoot the issue. That's why we will open port 22 and 80 on these instances. So to open or allow inbound traffic, we need to attach security group to the subnet. We will do that. Then once we have the subnet created, we are only left with the load balancer as well as auto scaling group. So we will first create a launch template, which is a prerequisite for auto scaling group. And once we have the launch template, we will create target group for the load balancer. Then we will create the load balancer. And finally, we will create ASG, auto scaling group, and associate the auto scaling group with target group. That way, load balancer will forward the request to the target group, and target group, because it is associated with auto scaling group, request will be forwarded to the virtual machines created by the auto scaling group. So this is the flow of the steps that we are going to follow. And where are we going to execute these steps? So previously when I, in our previous courses, when I used terminal to create these resources, few people found it difficult because, they were using Windows, I was using Linux environment. So this time I decided to use AWS Cloud Shell. So just go to the region that is nearest to you on your AWS account. So log into your AWS account, go to the region that is nearest to you and click on Cloud Shell. And you don't have to configure anything here. When you open Cloud Shell, so Cloud Shell is by default connected to your AWS account. For example, if I do AWS S3 LS, it will list out the S3 buckets within the AWS account. That means it is already configured with the credentials. Which credentials? The same credentials with which you logged into your AWS account. And for making it easy, I will duplicate the session. Basically, in one of the tab, we will create the resources using Cloud Shell. And in other tab, I will show you the resources that are created. Okay. So very simple. Here in this tab, we will create the resources. And on the other tab, whenever required, I will show you the resources that are created. Perfect. So the first step is that we will get the AMI ID, because AMID differs from region to region. So we will just get the AMI ID that we will be using for our instances. So AWS EC2 describe images, where I'm saying I want Ubuntu image with Ubuntu Focal 20.04. If you want, you can change the Ubuntu distribution as well. So when I click on the enter, I will get the AMI ID. In your case, this can be different. That's why I started with this command. Although I'm not going to use AMI now, it is needed when we will create the virtual machines. But lot of times I've seen people, they proceed with the commands, and when they head to the AMI, my AMI is different, their AMI is different. So, they get stuck at that point. So that's why I'm first fetching the AMI ID for my instances, that is the image ID, and I will just export it to a variable called AMI_ID. Cool. I will paste it here. That's all. Now we will go with our regular execution. So we will first create a virtual private cloud. So once again, all the steps are documented. Just go to our GitHub repository, go to the virtual machines branch. You will find complete deployment.md, and you can literally copy paste the commands, but make sure you go through the command, understand the command, just like what I'm doing here. Okay, AWS EC2, create VPC. What are we doing? We are creating a virtual private cloud with CIDR block and within this region. So what is this query doing? Very simple. Once the VPC is created, instead of going to the AWS console again, looking at the VPCs that are created, for example, right now there is only one VPC. As soon as I create this command or I run this command, a VPC is created. You can see here, if I refresh, you will find a new VPC 65. So this one here, and the same VPC number is printed on the terminal 062907. So you can see the VPC ID here. The same thing is printed on the terminal. Cool. So I will also export it. So export VPC_ID is equals to the VPC ID that we got. I mean, the reason for storing it in a variable is simple. In future, in the next commands, we will definitely use the VPC ID. For example, when we create a subnet, we need the VPC ID. So that's why instead of copying this every time, I just stored it in a variable called VPC ID. Right? So query parameter helped us get the VPC ID. Okay, we have the VPC. What is the next step? We will create the subnet now. As I told you, instead of a single subnet, we will create two subnets. So this is the first subnet that we are going to create. AWS EC2 create subnet VPC ID. So within this VPC, we are creating the subnets with CIDR range 10.10.1.24. The next subnet we will create, it will be with 2.24. And this will be in the availability zone AP South 1, if that is your region, or US East 1 A. The other one will be US East 1 B. Again, we are querying the subnet ID so that we will find it on the terminal. There you go. So we got the subnet ID. Let's do this. Export this as subnet_ID 1. Let's call this as subnet_ID 1 is equals to the subnet ID that we got. Perfect. Now let's do the next one. Okay, we are done with subnet 1. Let's do subnet 2. The only difference, as I told you, this will be 2.24 and availability zone will be US East 1A is this one, US East 1B is this. Okay. So let's export this as subnet 2. So I will remove this paste it from here. Great. And I will call this as subnet 2. So till now, we created VPC. We created 2 subnets within the VPC. Okay, we are going great. Next, once we have the subnets created, as I told you, to make the subnets public, we need the internet gateway. So let's create the internet gateway. AWS EC2, create internet gateway. Again, we are querying the internet gateway ID within this region. Okay, so let's export this. Export IGW underscore ID is equals to the internet gateway ID. Okay, we created the internet gateway. What next? We will create route table and associate the internet gateway with the route table, right? Or we can first associate the internet gateway with VPC. So let's do that. So we created the internet gateway. It's not associated to the VPC. First, let me do that. So AWS EC2 attach internet gateway. Where are we attaching? We are attaching it to the VPC. So internet gateway ID, VPC ID. Perfect. Now we will create the route table. Okay. So to create the route table, I have the command here. AWS EC2 create route table within the VPC. And once it is created, query the route table ID. Okay, route table is created. Now we have to create a route in it where the route will point the destination to the internet gateway. So for that, before that, let me also export it RTB underscore ID because I will use this route table ID. That's why I'm saving it. Perfect. So we got the route table ID saved as well. Now let's create the route. So AWS EC2 create route. Within this route table, we are creating a route where destination, you can see here, destination, CIDR block and gateway ID is the internet gateway. So we are having our route created where destination is from any, 0.0.0.0 refers to anything and gateway ID is the internet gateway. Cool. So this part is also done. Now finally, we just have to associate this route table with both the subnets. Only then they will become the public subnet. So let's do that. We will quickly associate the first subnet and the second subnet. So AWS EC2 associate route table, the route table ID to subnet 1, which is done. Now when I press on enter, subnet 2 is also done. Cool. So the first part of our networking is done where we created VPC, we created subnets, we created route table and associated the route table with the subnet. Cool. Now this is optional. You can tell AWS that whenever a virtual machine is created in the subnet, by default, provide it with a public IP. Most of the times this is enabled by default, but in case you disabled it previously for your region, this commands here will enable it. Very simple. You create a new virtual machine because these subnets are public, the instance will get a public IP address. Cool. Okay. Now let's create the security group as we discussed. So I will create security group again using AWS CLI. AWS EC2 create security group. This is the name of the group. And in the description, I'm saying allow the port 80 and SSH port within the VPC. And once the security group is created, I'm just querying the group ID. Okay, so we have the security group created. Let me export this. Export SG underscore ID is equals to this one. Now we just created the security group. We haven't allowed the rules within the security group. So let's also allow the rules. First, I will open port 80. So in the inbound traffic, authorized security group ingress, that is inbound traffic, the group ID, the one that we just created, where I'm allowing port 80 from everywhere. Now, just like port 80, we should also allow port 22, which is for SSH. So let's do that as well. So this time TCP port is 22. Cool. So we have both port 80 and port 22 also open. In your case, if you're using a different port, you can change the ports also. Now we will create the launch template. But for the launch template, we need user data. You can do it in two ways. One, here you can just open the Nano editor and you can copy the user data script from our Git repo. So within the virtual machines branch, you will find user data.sh. So you can click on the raw mode and you can copy it here and paste it on the terminal. That is our Cloud Shell. Or in Cloud Shell, you will already have Git installed. So what you can also do is you can run git clone followed by the clone URL. Okay, so scroll up. We have the clone URL here. Copy and paste it. So if you want the complete repository, you can do this. So you will have the intent classifier model, and here you will have the user data.script in the branch virtual machines. So what you have to do here, you have to just run git branch -a. You will find virtual machines branch. So you can do git checkout origin/virtual machines. Okay. Now if I do ls, I will have user data.sh here. Abhishek, I don't want to use git. Then yeah, you can use the Vim or the Nano editor, and you can also get the file copied from here. Anyways, okay. So I cloned the repo. I have user data.sh. Now for the launch template, I will run this command. So first I will take the user data and I will move this to the base64 encoding, because we are placing the user data.sh in a template file. Whenever you are dealing with template files, it can be JSON, it can be YAML, always base64 encode your script files. Because within a JSON, when you try to place a .sh or when you try to place a .sh within a YAML, you will run into formatting issues. Whereas if you convert it into base64, so it will be an encoded file or encoded string, which will be easy, just like a paragraph that you have written. Right? Let me show you for making it easy. So when I run this command, you will notice that entire shell script. Now if I just do echo $user_data, see, the entire shell script is converted into a paragraph format. So when you copy this paragraph format into a template file, you will not run into indentation issues. Whereas if I directly take the launch template, right? So cat user data.sh, if I directly take this and put this in the launch template, you can see here, there is indentation here. There are multiple spaces. You might mess up with the spaces and it will be very tricky to debug and troubleshoot. That's why not only in this case, even when you're dealing with Kubernetes, when you're dealing with Terraform resources, it is always easy to encode your script files. Okay, perfect. Now, when we create the launch template, we need few things, like we need the launch template name. So I will take those variables, export launch template name. Let me just call it this as MLOps template. Okay. Along with that, we need instance type. So I'll also export a variable instance_type. As I told you in the launch template, we will have the instance type, we will have the key value pair name, we will have AMI ID, right? So that's why I'm exporting these variables so that I can pass it in the launch template command. I'll use t2.medium. Actually, you can use t2.micro as well. But if you plan to run multiple queries, or if you plan to send multiple queries to the model, just go with T2 medium. Okay, instance type is also exported. Now I need a key value pair. In this region, I will search for key pair. Okay, and I will create a new key pair. This is only needed if you plan to SSH to the virtual machine. Okay, so here I'll create a key pair. I'll call this as MLOps key pair. Okay, RSA PEM file, create key pair. Okay, the key pair is also downloaded on my local machine. So MLOps hyphen key pair. Let's do that. So export key pair, or I'll call it as key underscore name, is equals to MLOps key pair. Okay, MLOps hyphen key pair. Is it the correct one? Yeah, MLOps hyphen key pair dot PEM. Cool. And finally, AMI ID, which I already have it. If I do echo AMI underscore ID, we got it in the very first step. So what did I export? I exported the instance type, I exported the key value pair, and I exported the AMI ID. Why did we do it? Very simple. Today, if you go ahead, create a new instance, these are the only three things that are mandatory to provide, right? So today, if you try to create an EC2 instance, you will provide the AMI ID, you will provide the instance type, and you will provide the key value pair. Of course, key value pair is not mandatory, as I told you, only for troubleshooting. So that's why even in the launch template, I exported these three variables. Cool. Now that it is clear, I will go ahead and I will run this command. So AWS EC2, create launch template, name of the launch template. This is the version of the launch template, and the launch template data. We are providing the AMI ID. We are providing the instance type. We are providing the key value pair. We are providing the security group, and also we are providing the user data here. So that's why we ran the command user data is equals to base64 encoded user data.sh. Let's run this. Okay, cool. So now the launch template is also created. Now we are only left with creating the target group, creating the load balancer, and creating the auto scaling group. Let's quickly do that. So we will start with creating the target group. Let's run this command. AWS ELB v2, create target group. I'm choosing the name of the target group as MLOps target group. This is the protocol. Port is 80 because we have Nginx configured on the instances, and Nginx is listening on port 80. VPC ID followed by basic health check. Okay, target group is created. I will copy the ARN of the target group and I will simply, okay, so here export target underscore group underscore name is equals to this one. Or instead of target group name, I will save it as target group ARN, which actually makes more sense, right? So I'll just call it as target group underscore ARN. Echo dollar. Let's just try to print it and see. Perfect. Okay. So we also saved the target group. Now that the target group is created, let's create the load balancer. Okay. AWS ELB v2, create load balancer. I'm calling the load balancer name as model deployment. I'm associating two subnets to the load balancer in two availability zones. security group, internet facing, done. I mean, this is also important. We have to make the load balancer internet facing. Just like target group, I'll also copy the load balancer ARN. Okay, so I will save this, export ALB underscore ARN is equals to this. Cool. So we have the ALB also created. Now we need a listener for the ALB, right? So imagine you created a load balancer. Okay, you created this, but it has to listen to the user's request. And only then what load balancer does? It listens to the user's request and it forwards to the target group. Listens and forwards. So we created the target group. We should also create a listener. So I will create a listener now. Going back here, perfect. So AWS ELB, create listener. For which ALB we are creating the listener? For the ALB that we just created, protocol port 80 forward. Okay, so we also have the listener created now. Now finally, let's create the auto scaling group. So I'll use this command for auto scaling group. AWS auto scaling, create auto scaling group. The name of the auto scaling group, I called it MLOps auto scaling. And the most important part is the launch template that we are using, MLOps template. Minimum I'm asking for 1 instance in the auto scaling group, and maximum I just defined as 3, considering you don't run into additional costs. But you can also set into 10, 20. Auto scaling group will create 20 instances if you have the user load. Okay, cool. So, okay, what does it say? You must have fully formed launch template. The key value pair mlops-keypair.pem does not exist. Okay, maybe our key value pair is not created well. Let's see. If I go back to the EC2, let's search for key pair here. Key pairs. mlops-keypair. Oh, okay. I mean, what we did is a silly mistake. So in the key value pair, whatever we stored it as a variable, we actually stored it as key value pair dot pem, but the name is mlops key pair. So here we stored the name of the key pair wrong in the launch template. So we have to fix that in the launch template. No problem. We will head to the launch template on the console. So here in the launch templates, I'll click on this. Okay, so we are in the launch template. This is the launch template, MLOps template. We will try to update the launch template. Okay, modify template. And here in the modified template, let's see where is the key value pair. So it should be here, mlops key value pair.pem. So let's select this, mlops key pair. That's the only change that we have to do in the launch template. Let's create template version. But we have to be little careful here when we go back to the launch template, right? If I refresh this, and because we made the change, if you head to the versions, you will find 2 versions here. Okay, so this is version 1 and this is version 2. So version 2 is with the change that we just created. So what we can simply do is we can make the version to default. Okay, set default version. Because this is what we need, right? The key value pair change. Okay, so now I will again go back, and here instead of version 1, I will call it as version 2. Or you can also ignore the version number so that the default will be picked up. Cool. So let's see. Now the now the auto scaling group is created. So it did not complete anything. That means the auto scaling group is created well. Yeah, it's quite common that, even though you have all the steps, when you perform demos, you run into issues. That's why I always recommend you to perform the demos. You will run into such issues. And during the issues, you can, troubleshoot the issue. In my case, I found it very fast because I do it multiple times. I deal with AWS resources throughout the day, very frequently. So that's why it was easy for me to identify the issue. Okay, so we created the auto scaling group as well. Finally, let's associate our target group with the auto scaling group. This is our final step. Once we associate our target group with ASG, we are all set. So the command that we'll use here, don't forget to refer our GitHub documentation because all the commands are there. And even if any of these commands get outdated, I will update that in the GitHub repo. Okay, so even if you are watching this course, maybe 4 years down the line, once I upload it, still, if you have any issues, you can let me know. I'll update the GitHub repo. Or if someone else reported, you will already find the command updated. Cool. Let's see what happens now. Okay, so it says auto scaling group is also associated with the target group. Now I think we are all set. Now if we go to the load balancer, that means we have created this entire architecture. Now we can verify it by sending a request to the load balancer, and load balancer should forward the request to one of the instances. Cool. So let's head to the LB. I'm in the VPC section, my bad. So here in the EC2 section, I should find the load balancers. Okay. So the model deployment load balancer is active. We should get the IP address here. So you can see what is it doing? It is listening to port 80. So whenever someone sends request to this DNS name of the load balancer, it will listen on port 80 and it will forward to MLOps target group. What is in the MLOps target group? You already know. The MLOps target group will have this particular instance. Who created this instance? This instance is created by the auto scaling group. Cool. Don't worry about the health status because we did not enable the health check API on the model. That's why it is showing you as unhealthy. You don't have to worry about it because we only enabled predict API on the model. That's the only thing. Okay, so the configuration looks perfect. We have load balancer. Load balancer is with the listener and that is associated with the target group. So I think everything should work well. Now, if I hit this DNS name, how will we do it? We'll go back to our local terminal. Okay, on the local terminal, we will run this curl command. Curl -x post followed by the ALB URL. So in my case, what is the ALB URL? The one I just copied. Okay, so the ALB URL followed by / content type application JSON. Let's see. Okay, so we are sending the post request to the model API, to the load balancer. Okay, so we got the intent as greet. Don't worry about this verbose. I actually enabled verbose output. I'll just remove it. Now you will just see the output. See, intent greeting. So you send the request to the load balancer. What happened here? Let's quickly write it down so that you understand it well. So we sent request to the load balancer DNS, right? Domain name. And from the load balancer domain name, request went to the target group. How did load balancer listen our request? Because we configured a listener on the load balancer. So from there, request went to the target group. We associated auto scaling group to the target group. So what this auto scaling group did, it said, hey, target group, I have one virtual machine. So whenever load balancer sends a request, directly forward it to this virtual machine. When ASG sees more load, so this ASG keeps monitoring the virtual machine. If it sees that virtual machine reached 80% of the limit, ASG will silently add a new virtual machine. And this time ASG tells the target group, hey, I have 2 VMs now. So now load balancer will balance the load between 2 virtual machines. Again, if the load increases, ASG silently adds a new virtual machine and load balancer will balance the request this time between 3 virtual machines. All of this is an automatic process, right? Imagine how wonderful this is. As cloud engineers, you don't have to be wake up at 2 a.m. in the night to see what are the resources on the virtual machine. ASG is doing it for you. So your 2 a.m. work of scaling up instances, scaling down instances to save cost for your organization is done by the ASG. And because ASG is associated with target group, load balancer is balancing the request between them. I know I repeated this multiple times, but that's the core of this topic. That's why I'm just making sure you all understand the concept. Cool. So now we implemented the model deployment end to end. Now, if you want, you can, extend your research. You can get to this instance. You can see how user data script is executed on this, right? And maybe you can also go through the configuration that is created, or you can just copy the public IP address, and instead of load balancer, you will notice you can directly make a request to this as well, because what we created is a public subnet. If you would have created private subnet and associated private subnet with load balancer, this would have failed. Okay, even from the instance IP, we get the response back. If you don't want this, do a very simple thing. Change this to private subnet. Don't associate routing and all, and connect the load balancer with the private subnet. Okay, so this is all for this lecture. I hope you will go back and implement it by following this documentation. Virtual machines branch on intent classifier model. In the next lecture, I'll show you how to delete the resources. Or even less than that, if you delete it right after you implement this project. So how to do that? I can provide you with a shell script, but the only reason for not providing the shell script is that, if you get stuck at a point, again, you will find it difficult to delete the resources, because in AWS, dependency between the resources is very complex. So you need to understand the exact order of deletion of the resources. So that's why I provided delete resources.md. You can follow the steps here and delete the resources in the same order. I'll quickly show you by deleting resources on my AWS account as well, so that even I don't run into cloud charges. So I'm deleting the setup now. First thing I'll do is I'll start with deleting auto scaling group, because end of the day, compute is the one that will be charged more on AWS. So I'll head to auto scaling group here. You cannot directly delete the auto scaling group. First, click on the auto scaling group here, and you will find the target group. You have to basically in the integrations, you will find the target group. So just edit and disable the integration. So this is the important part. Don't delete auto scaling group directly. Once you detach the target group, then you can just set the numbers here, the scaling limit, scale it scale down to 0, even this scale down to 0 and scale down to 0. Okay. Now this will delete the instances as soon as you forcefully delete the auto scaling group as well. By default, when you make it 0, auto scaling group should update the capacity back. But anyways, once this status is green, just click on the auto scaling group and forcefully delete it. If you can't, delete it by default. Okay, click on the delete. Deleting the auto scaling group, we will confirm once auto scaling group is deleted, we will go back to our EC2 instance and see if any instances are available. Right now, because I did not wait for the status to be green, I can still see there is one instance. Okay. If I would have waited for auto scaling group to delete the instance, and then if I deleted auto scaling group, I'm 100% sure that EC2 instances are deleted because I was quick. Let's see. Oh, anyways, yeah, even in this case, instances are deleted. That's awesome. Now I'll go back and I'll focus on the next important one, that is load balancer. So in the load balancer, first we will disable the listener. Usually we have to follow the same steps in which we created the resources. So first we will disable the listener, manage listener, delete listener. Okay, confirm. Cool. So listener is disabled. So now I can delete the load balancer. Delete load balancer, confirm. Awesome. So load balancer is also deleted. Now our next step is to delete the target group. So target group, let's try to directly delete it. Usually I have to deregister the target. Yeah, register target. I have to deregister it, but let me try by directly deleting it. Permanently delete one target group. Yeah. Oh, cool. So it worked. Sometimes, it might fail. Anyways, now we can go ahead and delete the launch template. So we created a launch template. Let's search for it. Launch templates. Okay. We just have one. I will delete it. Delete template. Okay. There you go. So the launch template is also deleted. Now we will delete the security group that we created. So in the security groups, this is the one, intent SG, actions, delete security group. Cool. So now we are only left with deleting the subnet, internet gateway, and VPC. Okay, first I'll go to the internet gateway, or first let me delete the subnet itself. So I'll head to subnet. Where is it? In the EC2, we should find, okay, my bad. We should search it in the VPC because it's the VPC networking. So in the VPC, I look for subnet, and we have two subnets here. So I'm just looking at the CIDR range. This is one and this is the other one. So first and the fourth one. Cool. I got a hold of it. Let's delete the subnet. Cool. So we have successfully deleted the subnet as well. Now let's delete the internet gateway. Again, that should be part of our VPC networking. Scroll down. Should be somewhere here. Internet gateway. NAT gateway. Yeah. Internet gateway is also here. Which VPC is it? So I think this is the one, 062. Let me double check. Don't delete the internet gateway of your primary VPC. Then you might run into issues. Yeah. So 10.10.10. This is in VPC 062. So again, go back and delete the internet gateway that is associated to the VPC that we created. So don't delete the internet gateway that is associated to your default VPC. You might mess up with your default networking. Okay, detach. Perfect. So we have detached it. Now let me delete internet gateway. Cool. Once again, it's very easy today to provide a shell script for the same thing. But if you get stuck at a point, the only problem is that sometimes you might leave it saying that you are stuck with deleting the resources. 10 to 15 days down the line, you will see a message from AWS that you are subjected to pay X amount because of the cloud costs. I don't want that to happen. That's why I'm showing you how to delete everything step by step. Okay, so we deleted the internet gateway as well. Now finally, let's delete the VPC. Which VPC? In my case, 062. Just scroll to your right and also confirm by looking at the CIDR range. Action, delete VPC. Delete. Cool. The other efficient approach of deleting the resources is that for every resource that you create, you can create a tag, right? For example, you created the VPC, create a tag, something called intent project or MLOps project, but that tag should be created for every resource, for VPC, for subnet, for route table, for internet gateway, and then you can use the AWS CLI to identify all the resources with the tag and delete all of those resources. That is another efficient strategy to do with AWS. Or if you use something like Terraform to create this entire resources, you can just run Terraform destroy. Again, that is also a good approach. Anyways, so in any of your case, make sure the resources are deleted. So this is about model deployment to virtual machines. So this concludes this section. I hope now you are clear with how model deployment and model serving is implemented in real time on virtual machines.